Hello, and welcome to this introduction to the Laboratory Risk Assessment Tool, the LabRat. I'm Harry Elston, Principal of Midwest Chemical Safety. This tool was developed by my colleague Dr. Neil Langerman of Advanced Chemical Safety and me about 20 years ago. It has over 40 person-years of experience behind it. The tool has been presented in numerous risk assessment workshops, and it is currently being used at Argonne National Laboratory. The tool is semi-quantitative. The user will assign scores to process categories that incorporate chemical hazards, physical hazards, and process hazards, and turn that score into an overall score for the entire process. The tool provides a way to step back and to evaluate a chemical process for safety. Using the tool will provide important documentation for safety professionals in the event of an abnormal or an upset condition, and it will also provide the documentation necessary to satisfy the evaluation for PPE assignment as required by the regulation. All risk assessment methods have their limitations, and the LabRat is no exception. The LabRat was designed for laboratory scale procedures only, usually less than 2 liters in size. Currently, there is no evaluation for the use of process logic controllers. Consequently, the LabRat tends to break down with the use of complex equipment such as large PLC-controlled pilot plants or flow reactors. With over 40 person-years of use of the LabRat, some observations can be made to its performance. First, chemists and those very close to the process will tend to underscore the risk. That is, they will tend to underestimate the risk associated with any given evaluation. Likewise, safety professionals who have little or no research experience or laboratory experience will tend to overscore the overall risk of the process. Therefore, it's imperative that after the RAT is performed, the user step back and ask, does this make sense? While the RAT can be performed by a single individual, risk assessments are always best performed in a group setting with those familiar with the process and everyone contributing to the discussion. Let's take a look at the RAT sections. The LabRat is an Excel workbook with 3 tabs. The first tab, shown here, is a place to document the overall process or procedure, process conditions, process controls, big picture job hazards, and environmental issues. Job controls here, qualified individuals, process conditions, if any equipment is needed, environmental issues, and other information. The second tab is the scoring section for the RAT. Scoring is accomplished by choosing the appropriate hazard and then placing an X under the level that's appropriate for the experiment. Each section is fairly self-explanatory, but I'd like to point out some special considerations. The hazard recognition section, second section here, is auctioneered. That is, only the highest score from each of these categories, flammable, corrosive, toxic, or cryogenic, is scored for the overall scoring for the RAT. Take a look. For example, if I have a 3-4 flammability, but a 4 for corrosive, only the 4 is scored. As you fill out this section, keep in mind you'll have to make some determinations between no hazard, 0 or none, and extreme hazards, the 5 scores, 4 and 5. For example, concentrated nitric acid in a process may be scored a 4 or a 5, while 0.1 molar nitric acid would be scored quite a bit less, maybe a 1. 2 special hazards are called out. These can be thought of as force multipliers or risk multipliers for the risk assessment tool. If the process involves reactive chemistry, for example the use of pyrophoric material, that is scored separately and added into the overall score. Likewise, if the process is using a chemical that has been identified by the United States Department of Transportation as toxic by inhalation, that is also added to the mix. Process conditions are the next section. The farther you are from ambient pressure and temperature conditions, the higher the section is scored. After the sections are complete, a final score will be shown in the green box here with recommended actions based on that score in the yellow box right below it. If you need any help on decision making, the third tab provides a scoring aid that can guide you or give you suggestions on how to score certain areas. Now let's run through an example of scoring for a common undergraduate experiment, aspirin synthesis. An abbreviated version of the synthesis was taken from the Cal State Stanislaus Chemistry website back in 2013. This is a very common synthesis that is performed either late in general chemistry or early in organic chemistry. Sometimes it's even performed in high school AP classes. We see on the next two slides a summary of the procedure that we'll be using to score the risk assessment tool. Here's the first page of the tool for the assessment. Title, date performed. In this section, we simply put down see the laboratory manual, pressure and temperature ranges, job hazards that we'd expect, and job controls. The procedure is typically performed in an Erlenmeyer flask, and the total volume of chemicals that will be used is less than 500 milliliters. Place an X in this volume box here. For hazard recognition, ethanol is used to purify and recrystallize the product. The flash point of ethanol is 14 Celsius or 57 degrees Fahrenheit. It is categorized as a GHS Category 2 flammable liquid. If we use the scoring guide, it would be listed as a 4 for flammability in the risk assessment tool. Acetic anhydride is also a combustible liquid, but it would not score higher than ethanol in the RAT. However, acetic anhydride is corrosive and it's a powerful lacrimator. I will list it as a 3 under corrosive and as a 3 under toxicity. We're not using any cryogens. Notice under hazard recognition, the section is auctioneered where only the highest score is carried forward to the score. The experiment is not particularly reactive, nor does it involve any Department of Transportation toxic by inhalation chemicals. Place an X under the 0 for each. The process conditions are not extreme. We will be heating the reaction in a hot water bath, 70 to 80 degrees Celsius, and also be using vacuum filtration. I'm going to judge it as 1 for the process conditions. There are no explosion, radiation, or other hazards that should score. Place an X in the 0 category for each. The procedure as it was given to you on the previous slides is pretty sloppy, and I would expect it to be much more detailed for a student. Let's score that as a 2. When students are performing this experiment, I would not expect them to be fully trained, but I would expect them to be supervised by a knowledgeable instructor. Let's score personnel and preparedness as a 3. We will assume that a laboratory chemical hood is being used for the experiment, and that will score a 0. No shielding is needed. And what about equipment maintenance? Well, in most academic places, it's somewhere between never performed and rarely performed. Let's score that a 2. The final RAT score is 13. Now perform the final check. Does this make sense? It should. We know that this experiment is routinely performed in first and second year chemistry courses, and we also know from experience that we generally do not allow first and second year undergraduates to perform high risk or high hazard work. Another feature of the risk assessment tool is that it allows you to identify areas where risk reduction or process improvement can take place. For example, we could write a very detailed written procedure and score that as 0. and keep all of our equipment under a preventative maintenance program and score that as 0 as well. And if we take a look, the score is lowered even more. And there you have it, the LabRat. I hope that it's a useful tool for you. Thank you for watching this presentation on the Laboratory Risk Assessment Tool, the LabRat. If you have any questions about the tool or any chemical safety questions in general, please contact me at harry@midwestchemsafety.com or check the website at www.midwestchemsafety.com.